In this next video, we're going to talk a little bit about moving averages. So in our last video, we looked at average value of a function, which took the area divided out by the length to give us the average height of a function over an interval. For a moving average, what we're looking at is we're going to be using kind of the same notion to look at period-adjusted average values of a function. And what I mean by that is, let's look at this example here. So here I've got a graph of a function over some interval, and I'm going to break this up by, let's say it's profit earned per month. So I can see here in January we earned about $3,000, here in April we earned about $3,000, in May it was about $5,000, and so forth. And so what we mean by an average value is, and I'll use the blue here to denote the average value over the 7-month period. Okay? And again, all that's saying is if I look from January all the way out to July, the average height of the function is designated by that average rate of change. Okay? So I can figure out the average value for the whole interval. When I'm talking about a moving average, I'm basically taking this longer period and subdividing it into smaller periods and looking at how the average is changing from those subperiods to the next subperiod. So let's say here I want to look at the moving average every 2 months. Okay? And so what that's saying is if I look at the beginning of January and then I go to March, I'm going to get a moving average for that month, 2-month period. And then I can look from February to April, and there's going to be another moving average from there. And then from March to May, which is up here at this 5-month, there's an average value there. And so you can see that the averages for each of the 2-month periods, first off, are very different than the 7-month average, but also from every 2-month period to the next 2-month period, they're going to change. And so that's what this moving average is. It's the changing averages from each of the subperiods to the next successive subperiod. Okay? All right, so there's kind of what we mean pictorially. Okay? So to find what we call the n-unit moving average, we'll take an interval of length n and calculate the average value of the function over that interval. Now again, depending on what our function is and what the units are, these can be very different subperiods. And so n here is considered arbitrary depending on the number of moving averages we want. So we denote this f sub n with the bar. So again, the bar means I'm looking at an average value. The n tells me I'm looking at an n-unit moving average. It's going to be 1 over n, so again, 1 over the length of our subinterval of our function over the length of the interval. Okay? And in this case, because we're not looking at the whole interval, so normally we have an interval from a to b, here because we're looking at a subinterval, we want that in terms of x, and it's an n-unit length over that subinterval. So again, x minus n to x gives us an interval of length n. Notice here we change the variable of integration, and that's because our limits are in terms of x. So we don't want this to be f of x anymore, we'll just change it to f of t. Okay? This again is our formula for the n-unit moving average. And again, just like average value and some of our other formulas, this is a formula you're going to need to know for the exam. Okay. So in this section, you're going to be asked to do 2 different types of things with the moving averages. Both are calculating end unit moving averages, but your setup is going to be a little different for the two different types of problems. So in this first type, you're going to be given some information about a situation. So in this case, we are given the stock prices for oil each December of a 12-year period. And so it's given to us in a table format, and it has each of the years broken out and, of course, their corresponding stock prices. And what we want to do is find the end unit moving averages. For this type of problem, you're going to be asked to do one thing, and that is to find the end unit moving average. Okay? So in this example, we've got two different types we're looking for. Given this table of information, we want to find the 4-year moving averages, and we also want to find the 6-year moving averages. Now, in both cases, basically what we're going to do is we're going to set up a table that gives the information kind of like what we were given. Okay? So in this first case, if I'm looking at 4-year moving averages, my table is going to look like the following. For each of the 4-year periods, so we have the period from 2001 up to 2004, 2008 to 2011, and 2009 to 2012. Okay. All right. So for each of these 4-year periods, we want to come up with the average value of the stock price. And again, all that's saying is, well, for this 4-year period, I'm going to look at the average stock price, meaning I'm going to add up those 4 stock prices and divide by 4. And that's it. That's as easy as it is. The long part, or the hard part of these problems, is based on the N in your moving average, how many of these you're going to have to do. So the bigger my N, the more numbers I'm going to have to average. The smaller the N, the more averages I'm going to have to find. Okay? And so in this case, if I look at my 4-unit moving average, so for 2001 to 2004, 39 plus 35 plus 41 plus 51, I'm going to add those up and divide by 4, and I'll get 41.5. Now, your answers in here, usually in your problem, it will tell you where to round these. Most of these are going to come out fairly nice, especially if I'm looking at an even number moving average. If I'm looking at like a 3-year or a 5-year or 7-year or something like that, I'm going to come out with some not so nice numbers. And so there it will usually tell you where to round a little bit nicer. Okay? Most of these, depending on the types of things you're looking at, in this case it's stock prices, so I can round to the nearest cent. If I'm looking at average gallons or average profit or things like that, it's going to depend on what my units are to determine where I'm going to round, especially if it's not stated. But now I'm going to do that for each of them. So now from the 2002 to 2005, I'm going to take the next 4, add those up and divide out. So we'll get a 45.75. Same thing in the next one. And I'm going to go ahead and just keep adding the 4-year all the way up until I get to my last one. Okay. And so there would be one version of my table. In some of your problems, like in WebAssign, they will extend this table. So I'll have the 2 columns, or 2 rows, my year and my stock price, and then they'll give you a 3rd row for your moving average. And for each of those, I'm going to put it in at the end value. So for example, in 2001, if I'm filling in kind of my moving averages in here, there wouldn't be a moving average in the first year because I don't have 4 years worth of data. Likewise, in the 2nd and 3rd year, I don't have 4 years worth of data, so those would be just left blank. And then in this next year, that's where I would put in my 41.5 and so forth. And from there, I'd be able to fill in the rest of my table. Okay? So it just depends on how it's asking you for this information, whether you're going to create your own table or add to what's already there. Okay? In the second part of this example, we want to find the 6-year moving averages. So now maybe we want to do this every 6 years, and we want to figure out what things are changing. So again, I can set this up the same way. So I'm going to look at from 2001 up to 2006, from 2002 to 2007, 2003 to 2008, 2004 to 2009, 2005 to 2010, 2006 to 2011, and 2007 to 2012. Oops. Okay. And so again, setting up my table. Now again, I can plug in my different values. Same thing if I was doing a table like an extension of my data that I'm already given. In this case, since I'm looking at a 6-year, for the first 5 years, I would have dashes. So again, dash, 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 and dash, and then I would fill in my average for that 6th year. Or if I'm going to set up my own table, I can set up my intervals, my subintervals for each of the different years, and go ahead and put in my moving averages there. So here again, same thing. I'm going to take the first 6 years. So I'm looking at these 6 data points. I'm going to add them up and divide by 6. Okay? And so doing that, I'm going to get a 49.83, and lastly 73.17. Okay? And so we can see with these some trends. For example, in this case, we can see that the moving averages are increasing up through 2011, and then in that last 6-year period, it goes down a little bit. We can see here our highest one happened to be the 2006 to 2009, so if I'm looking at 4-year moving average, that was the moving average where my stock rates were the highest. And you can pull information off of these. So in WebAssign, you'll be asked to do something like this, and then you'll be asked a question like, well, which 4-year period or which 6-year period had the highest moving average? Or which one had the smallest moving average? Or what can be said about the general trend of the stock prices? And in all of these, we can see it's mostly increasing except towards the end, in both cases, where it does a slight decrease. Okay, so we'll be asked to pull some information off of the moving averages. The second type of problem you're going to see in terms of moving averages are ones where you are given a function, and based on that function, you're asked to find the moving average. Okay. So here's an example of 2 of those. In this first one, we want to find a 5-unit moving average for the function f of x equaling x to the 2/3. Okay, so this again is going back to just having the equation and finding the function for the moving average. Because here I'm not going to be able to find specific values because I don't have data values for each of the subunits. Okay, so the most I'm going to be able to do is to come up with a function for my moving average. The formula for my n-unit moving average says it's going to be 1 over the number of units, the integral from x minus n to x of f of t dt. Okay, so here what we're going to do is we're going to put in the n that we want, in this case the 5, and we're going to put our function in terms of t, which in this case is our x to the 2/3. So our f bar sub n is going to look like 1/5 the integral from x minus 5 to x of t to the 2/3 dt. Okay. And then from here, we're just going to use our fundamental theorem of calculus to get our antiderivative and evaluate at the limits. So the 1/5 gets carried along, and then from here we'll take the antiderivative, which is going to look like a t to the 5/3 multiplied by a 3 over 5. We're going to evaluate that. So there's the antiderivative, evaluated from x minus 5 to x. Okay, so we can go ahead and combine. So we'll get 3/25. Plugging in at the upper limit is going to be x to the 5/3 minus at the lower limit, plugging in, so there would be our antiderivative. And again, notice this is a function. I can't simplify this down much more. So my 5-unit moving average is this function here. So now once I know my interval, so let's say my interval was from 0 to 10 or 0 to 20, then I can figure out what my 5 subintervals are, and I'll know exactly what my x is going to be. Alright, so let's look at another example. In this case, we want to look at the 3-unit moving average for the function absolute value of 2x plus 3 over 2x plus 3. Now, again, the idea is exactly the same. I'm going to use my n-unit moving average, which is 1 over n, the integral from x minus n to x of my function in terms of t dt. Now, the difference here is, well, my function is a little bit more complicated. Okay? So here, my 3-unit moving average is going to look like 1/3 the integral from x minus 3 to x of my function in terms of t. So 2t plus 3 inside the absolute value over 2t plus 3 dt. Okay. Again, getting my antiderivative. Well, here, this function, like I said, is a little bit more complicated, but if I look at it, it's an absolute value over a function. And notice the function is exactly the same as what's inside the absolute value. So if you remember, I'm just going to do this off to the side. If you remember, when I took the derivative of the absolute value of x, this turned out to be absolute x over x. And so here, if I want to integrate the absolute value of a function over that function, I get just that absolute value. So here, my antiderivative is going to be 2t plus 3. But notice here I've got something other than just x. So using our u substitution, we'll see we'll also get a 1/2. And we're going to evaluate that from x minus 3 to x. Okay. Again, we can clean that up and evaluate using our fundamental theorem. So the upper limit minus the lower limit. So we'll get a 1/6 at the upper limit, 2x plus 3, minus at the lower limit, we're going to plug in the x minus 3, and we can clean that second absolute value up a little bit more. So 1/6, 2x plus 3, minus the 1/6, 2x minus 6 plus 3. So there would be our 3-unit moving average. Now, on your homework, you're going to see both types of these n-unit moving averages. The ones where you've got the table, but also the ones like this where you're given the function and you're finding the n-unit moving average function. Okay. On an exam, you would be asked to set up this type of a problem, meaning given the function, be able to set up this integral and evaluate it for nice functions. But you're also going to see some of the table ones. And of course, those are not going to be as extensive as the ones you'll see in the homework, but you'll be asked to do some of the table ones as well, maybe with a lot fewer data points than you would have in the homework. Okay? So understand your n-unit moving average and be able to calculate the function as well as the actual values for the subintervals.